Okay, so let's finish the backside of 4-7. So we're coming to these problems here. Ultimately, we're finding sine, cotangent, and cosine of some thing here in parentheses. All of these things in parentheses are inverse or arc sine cosine definitions. If I were actually to be able to find the arc cosine of 3x, which you can't, you don't know what x is, wouldn't this answer be a degree measure in radians? Agreed? So my ultimate goal in finding the sine of some degree measure isn't it a ratio of sides? Plane sine, plane cotangent, plane cosine, the answers are all ratios of sides. So I don't really have to know what the degree measure is. Just like on this one, did I have to know what the degree measure was to find secant? We used the arc sine, knowing that that was a ratio of sides, to figure out what quadrant we belonged in, and then consequently what were the ratio of the sides. And then we found the third side by using Pythagoras theorem. We used our knowledge of the side lengths of theta prime, we don't even know what theta prime is, to actually find the secant. We use that same theory in philosophy here when you have variables. You have to make a couple of assumptions, and in your homework math Excel, they should probably write these out. But my assumption is that x is positive, and that x is going to be restricted in such a way, thank you, Samantha Mitchell, at my convenience, so whenever I'm done. X is going to be restricted in such a way that you're going to end up in quadrant 1. And with x being positive, you'll see how we end up in quadrant 1 anyway. So let's go ahead and go through and find each of these three. So for this first one, our first step always is to figure out what quadrant we're talking about. So ignore the sign on the outside. Look just at arc cosine of this thing, 3x. Because it's an inverse, I know that this is a ratio of sides. So I know that that should be 3x over 1. And because it's cosine, I know that cosine is adjacent over hypotenuse. So they've given me 2 of the 3 sides of my triangle, sort of, an expression plan. And I have to figure out what quadrant it's in. Because it's our cosine, we're assuming this is positive. Where is cosine positive? Where's cosine positive? 1 and 4. Where is arc cosine restricted to? 1 and 2. So that means that my reference triangle is in quadrant 1. So this is where theta prime is. I don't know what theta prime is. You'll see that it won't matter. Then I'm going to use these ratios to set up the side lengths of my reference triangle. So adjacent would be 3x, and my hypotenuse would be 1. I'm left with trying to figure out this third side, and I'm just going to name it whatever I want to, as long as I don't name it x. Now, I choose y. You could choose A or B. I would suggest that you don't choose C, y. In a right triangle, C usually belongs to what? The hypotenuse. So I wouldn't use C or x. How am I going to find y? Pythagoras theorem. That's exactly how I'm going to find it. So I'm going to take my legs, 3x, I'm going to square them and add them together and set them equal to my hypotenuse, which in this case is 1, and it's got to be squared. So 3x squared is 9x squared plus y squared equals 1. I'm solving for y, so move the 9x squared over. Y squared is equal to 1 minus 9x squared. How do I solve for y? Take the square root. Normally when I take the square root of both sides, you should have a plus or minus, but y is a distance, and distance is always positive, so we're going to ignore the negative. So y is equal to the square root of 1 minus 9x squared. I cannot take the square root of 1 and the square root of 9x squared and then subtract them. It doesn't work that way. This factors as 1 plus 3x times 1 minus 3x. It is not a perfect square underneath it. So that's fully simplified. This becomes the value up here to that side. So that's how we end up with y equaling the square root of 1 minus 9x squared. Now that I have all 3 sides, all I'm left to do in my third step is to find the sine of theta prime. Ultimately, my goal is to find the sine of the same angle. Remember, this is going to give us an angle measure. Well, the angle measure we came up with was theta prime. Well, I'm going to find the sine of that angle measure, which is a ratio of sides. If it's sine is what over what? Opposite of the hypotenuse, and our side opposite of theta prime is the square root of 1 minus 9x squared divided by my hypotenuse, which is 1. That does simplify to the square root of 1 minus 9x squared. You can't write it over 1. So you can get an expression as an answer. The only complicated part is finding the missing side using Pythagoras theorem. The rest of it should be a piece of cake. You get the process. Let's do another one. So this time we're ultimately finding cotangent. In order to find cotangent of, this is going to give us an angle measure of theta prime, I have to know my sides. So let's figure out what quadrant we're in. Ignore the cotangent. Just look at our cosine. We're assuming x is positive. So, where is cosine positive? 1 and 4. Where is arc cosine restricted? 1 and 2. So where's my reference triangle? Quadrant 1, and here's theta prime. So because it's cosine, this is really x over 1. I'm going to see it as a ratio. And cosine is adjacent over hypotenuse. So adjacent to my theta prime is x. My hypotenuse is 1. And then again, as I did before, I'm going to let that equal y. What do we do next? What do I do now? Find y using what? Pythagoras theorem. I'm going to take my legs, x, square them, and add them together. And set them equal to my hypotenuse squared. So to solve for y, I want to move the x squared, so I get 1 minus x squared, and then take the square root. And so y ends up equaling the square root of 1 minus x squared. Again, I can't pick the square root of 1 and x. That factors as 1 plus x, 1 minus x. It is not a perfect square. So my value for y is this. So now that I know all three sides, I can actually find the cotangent of theta prime. So I've converted the arc cosine of x to this theta prime. Cotangent is what ratio? What over what? If tangent is opposite over adjacent, then cotangent is adjacent over opposite. And so let's see what we get. I guess I'll do it over here. My adjacent is x. My opposite is the square root of 1 minus x squared. I will take that as an answer, unrationalized, you're welcome. I believe math Excel will too. Mostly because as we enter calculus, we put rationalizing denominators often. That makes sense? Yes or no? If something doesn't make sense, you gotta ask. Okay, so let's do the last one. So it's just a slight change in notation. It's still inverse tangent arc tangent. So again, my step 1, you've got to figure out what quadrant you're in. We're assuming x is positive. So where is tangent positive? You're ignoring cosine right now. 1 and 3. Where is inverse tangent restricted? 1 and 4. So doesn't my reference triangle end up in quadrant 1? No small surprise. There's theta prime. So my ratio is x over 1. Tangent is normally opposite over adjacent, well, it always is. And so opposite of theta prime is x, adjacent is 1. We could call this C, I'm still going to call it y to maintain consistency. I don't know, are you ignoring me or are you taking notes? Just check. Alright, so find y. So my legs will be 1 squared plus x squared is equal to y squared. Well, y is already by itself, so I can just take the square root of both sides. Get y is equal to x squared plus 1, the square root of that, or you could have 1 plus x squared. And again, I cannot take the square root of x squared and 1. And x squared plus 1 is not factorable. This is not a perfect square. It's very simplified. So this becomes my value for y. And so y is equal to the square root of x squared plus 1. Hard to read a little bit there, but it's x squared plus 1. So all that's left is to find the cosine of theta prime. What might that be? We want adjacent over hypotenuse, which what's adjacent? Adjacent. 1 and my hypotenuse. So x squared plus 1. And again, I'll take that unrationalized. Any questions on that? Yes. No. Those are interchangeable. This one, not so interchangeable. You don't have to have a negative over the x squared. Alright, so you're good with that?